Parametric equations, part 5, speed and arc length, where instead of arc length, I might ask for total distance traveled. Reminder, the position vector, p of t, is x of t, comma y of t. And then our velocity vector would be x prime of t, comma y prime of t. Or sometimes they use the notation v sub x and then v sub y. The acceleration is x double prime, comma y double prime. So how can I find the speed of an object? Well, the speed of something is the magnitude of velocity. Here is the magnitude of our velocity vector, where magnitude is often given as absolute value. Now, I'm old school, so sometimes I write the double bars. But a lot of textbooks that I see nowadays use a single bar. But it's the magnitude of velocity. It's how big the velocity vector is. So how big is a velocity vector? Well, if I break down my velocity vector in the picture into my x component, which is x prime or dx dt, and then my y component, which is y prime or dy dt, then the Pythagorean theorem gives me the magnitude of my velocity vector, which is the square root of dx dt squared plus dy dt squared. Let's do one problem finding speed. So let's let our position vector be given by, let's say, t cubed, comma, sine of pi t. And let's find the speed at t equals 1. We need to start by finding our velocity vector, which is 3t squared, comma, pi cosine pi t. And then our velocity at 1 is 3, comma, pi times the cosine of pi, which is negative 1. And our speed then is the magnitude of our velocity vector at 1, which is x prime squared plus y prime squared, which is the square root of 9 plus pi squared. Pretty straightforward. Now, what if we wanted to find the arc length or total distance traveled, where when we're doing total distance traveled, we assume if I start, say, at A and go to B, I'm not going back and forth, that I'm continuing in one direction. Because if so, if my parameterization allows that, then arc length and total distance traveled are the same thing. So how do I find the arc length? And let me start back in rectangular, y equals f of x. Because it's very similar finding arc length in parameterized form as it is in rectangular form. So, always in calculus, or very often I should say, when I want to find something, a length in this case, I start by taking a simple shape, or a known geometric shape, and then finding its measure, in this case length, and adding all of those together, and to find the actual length, I would shrink my width down to 0. So again, I'm not doing velocities right now. I'm just doing y equals f of x, and I want to find arc length, where that distance is delta x, and that distance is delta y, and similarly for both. Then one of those distances would be the square root of delta x squared plus delta y squared. And if I shrunk it down, right, and then added all of these pieces together, I would get the sum of dx squared plus dy squared. Now, I'm going to call this S instead of D. S is a typical letter that they use for arc length. But how do I evaluate an integral that looks like this? Well, let's do a little bit of algebra. And let's do the following. Let's factor a dt squared out of both pieces, even though there wasn't a dt squared to begin with. But if I do that, I could rewrite this as dx over dt squared plus dy over dt squared. If you're unsure, multiply this back out, and you'll see you get where you started. And then doing a little bit more algebra, I get my arc length S is the square root of dx dt squared plus dy dt squared. And then I can factor out or pull a single dt out of the square root. And that gives me the arc length formula. One thing I'd like you to notice is that the arc length, or total distance traveled, is the integral of speed, dt. We'll do one really simple example that we don't actually need calculus to evaluate, but it's pretty hard to find integrals that work out nicely by hand, so I'm going to do one that I know works out nicely by hand. So let's find the parameterization. Let's say let x equal 4 cosine t and y equal 4 sine t. And we want to find the arc length, or total distance traveled by a particle, if you would, on the interval 0 to 2 pi. So how do we find the arc length? Well, I need to find dx dt, which is negative 4 sine t. And I need to find dy dt, which is 4 cosine t. And then my arc length is the integral from 0 to 2 pi of dx dt squared, which will give me 16 sine squared, plus dy dt squared, so 16 cosine squared, and then dt. All we have to do now is simplify. So we get that the arc length is the integral from 0 to 2 pi of the square root of 16, factor out, sine squared plus cosine squared dt. So our arc length is the integral from 0 to 2 pi of 4. Right, because this sine squared plus cosine squared equals 1, and the square root of 16 is 4. So we get 4t from 0 to 2 pi, which equals 8 pi.